This is Mr. Martin. These are the video notes for Investigation 4.2, Properties of Isosceles Triangles for Geometry Advanced. And here's your learning targets, so make sure you read through those and revisit those later to make sure that you are progressing with the learning targets. And if you remember from Chapter 1, an isosceles triangle is a triangle with at least two congruent sides. Okay, some books define it as exactly 2, but our book defines it as at least 2. Both ways are correct. So, in an isosceles triangle, the angle between the two congruent sides is called the vertex angle. So let's go ahead and label that. This angle up here is our vertex angle. And the other two angles are called the base angles. So I have this angle over here and this angle over here. These are the base angles. And then the sides between the two base angles, or the side between the two base angles is called the base. So over here I've got the base, and it's important that you know all these different parts. And then the last two sides that we have, these are called the legs. So I have a leg on the left and a leg on the right. The way this is oriented, these are the legs. So make sure that you know what the different parts of an isosceles triangle are. So there's the parts. And then we know that these two sides are congruent. And if we constructed a whole bunch of isosceles triangles and then we measured the base angles, we would come up with the isosceles triangle conjecture, which says if a triangle is isosceles, then its base angles are also congruent. Alright, so just keep in mind if it's isosceles, look for those tick marks, look for any other information that would indicate that it's isosceles. Just know that if the legs are congruent, that the base angles will also be congruent. So equilateral triangles have at least two congruent sides. So they fit our definition of an isosceles triangle. So any properties that we have for isosceles triangles will also apply to equilateral triangles. So how would this isosceles triangle conjecture apply to equilateral triangles? Well, since all sides of an equilateral triangle are congruent, then all the angles will also be congruent. Okay, so with an isosceles triangle, we have two congruent sides and two congruent angles. With an equilateral triangle, we have three congruent sides and three congruent angles. So we could also say it is equiangular as well. So equilateral, equiangular, talking about the same triangle. Alright, so let's look at the converse of the isosceles triangle conjecture. It would say if a triangle has two congruent angles, then it is isosceles. Alright, let's look at a few examples. So for each of these examples, if you wanted to go ahead and pause the video and try and work them on your own, that would be great. Otherwise, you can follow along as we go. So for the first problem, notice the two tick marks here. Since I know that these two sides are congruent, I know that the angles that are across from them, so this angle and this angle, are also going to be congruent. So I know that this angle is also going to be 51 degrees. And we learned in lesson 4.1 the three angles of a triangle always add up to 180. So I know that x plus 2 times 51, because both my base angles are 51, is going to be 180. So x plus 102 is equal to 180. Subtract 102 from both sides, and I get that x is 78 degrees. As always, if you have questions, make sure that you take the time to pause the video, write down your questions, and then you can ask me the next time you see me. Moving on to example 2, again here are my two congruent sides. So these are going to be my two congruent angles. So if this angle is x, this angle here also has to be x. So the sum of my angles would be 2x plus 28. Those are the three angles of my triangle. We know they have to equal 180. Subtract 28 from both sides. I get 2x is equal to 152. Divide both sides by 2, and I get x is 76 degrees. Alright, moving on to number 3. Again, pause the video anytime you need to get caught up or rewind or in order to write down your questions. Alright, so for number 3, here's my two congruent sides. So I know that my angles across from those are going to be congruent. So I know that this angle here is going to be 46 degrees. And I know that angle 2 is equal to x plus 94. So I know that x plus 94, that's my vertex angle, plus 2 times 46, those are my base angles, have to add up to 180. So combining like terms here and here, I get x plus 186 is equal to 180. Subtract 186 from both sides, and I get x is negative 6. So it's okay to have a negative value for x, because when I go ahead and plug that in up here for the measure of angle 2, I'll get a positive number for that. We can't have a negative angle, but we can sometimes have a negative value for x. Alright, moving on to our last example. I know that these two angles are going to be congruent, so I'm going to have two angles that are 79 plus x. So I have 2 times 79 plus x, and then my third angle here is 36. I know that has to equal 180. So I'm going to distribute over here. So I have 158 plus 2x plus 36. Remember, when you distribute, you have to multiply it by everything in the parentheses, is equal to 180. I'm going to combine my like terms over here. So I get 2x plus 194 is equal to 180. Subtract 194 from both sides. I get 2x is negative 14. Divide both sides by 2, and I get x is equal to negative 7. Alright, so if I wanted to check, I could go ahead and plug this back into there, and then add up the measure of angle 2, my other base angle, and 36, and make sure that I got 180. So you can always check these. And again, if you had any questions, make sure that you write those down and ask me when you see me. And also make sure that you're keeping up with the homework in the book. Those are the most important problems to be doing to be preparing yourself for quizzes and tests. Alright, that's it for this video. We'll see you next time.